The bag placed on the aisle, being in contact with the bus, also comes into motion and moves forward. Thus, during the bus ride, the bag is found near the front seat after some time. IV. Strong support should be provided while firing a bullet from a gun. Answer. According to Newton's third law of motion, every action has an equal and opposite reaction. When a bullet is fired from a gun, the gun exerts a backward force reaction on the person. Therefore, strong support is needed to counteract this force. V. When two rubber balls of the same size were dropped on the floor, one is seen to bounce more than the other. Answer. The difference in bouncing is due to differences in elasticity. The ball that bounces more has greater elasticity, allowing it to recover its shape better after impact, while the other ball may have less elasticity or more energy loss due to internal friction or material properties. B. A rubber band should not be stretched beyond a certain limit. Answer. Stretching a rubber band beyond its elastic limit causes it to lose its elasticity and undergo permanent deformation plasticity. This can lead to the rubber band breaking or not returning to its original shape. 4. Answer the following questions. I. Define average velocity and acceleration. Average velocity. The total distance covered by an object divided by the time taken to cover that distance is called average velocity. Its SI unit is meter per second. Acceleration. The rate of change of velocity per unit time is called acceleration. Its SI unit is meter per square second. E. Prove the following equations related to the linear motion. A. V equals U plus at. Proof. Assume an object in linear motion has an initial velocity u time t, acceleration a, and final velocity v. According to the definition of acceleration, acceleration equals final velocity, initial velocity time, or a equals v u t, or at equals v u. Therefore, v equals u plus at proved. V squared equals u squared plus 2 as. Proof. Assume an object in linear motion has an initial velocity u time t, acceleration a, final velocity v, and displacement s. Displacement equals average velocity times time, or s equals v plus u 2 times t, or s equals v plus u 2 times v u a, since t equals v u a from a equals v u t, or s equals v squared minus u squared 2a, or 2 is equals v squared minus u squared. Therefore, v squared equals u squared plus 2 is proved. C s equals u plus 1/2 at squared. Proof. This equation can be derived using the definitions of average velocity and acceleration. Displacement equals average velocity times time, or s equals u plus v 2 times t. From v equals u plus at, substitute t equals v u a. S equals u plus v 2 times v u a. However, a more direct derivation uses the fact that s equals initial velocity times time plus 1/2 times acceleration times time squared, or s equals u plus 1/2 at squared. This is derived by integrating acceleration over time, considering constant acceleration in linear motion. Proved. E. Draw a displacement time graph and a velocity time graph to show the linear motion of a moving object with uniform velocity. Displacement time graph. Velocity time graph. IV. Draw a displacement time graph based on the given data. Study the slope of the line on the graph and mention the nature of the motion. Calculate the average velocity of the first 4s of the object using the slope of the line. Time s 0. 2, 4, 6, 8, 1, 0, 1, 2, 1, 4. Displacement m 0. 4, 8, 8, 1, 2, 8, 4, 0. Answer. While studying the slope of the displacement time graph, the nature of the motion is non-uniform. Average speed in section OA equals slope of the displacement time line OA equals slope between point 0, 0, 0 and point A, 4. 8 equals 8, 0, 4, 0 equals 8 quarters equals 2 meters per second. V. The motion of a hare and a tortoise, from the famous story of Hare and Tortoise, is demonstrated in the given graph. By studying the graph, rewrite the story including every step of moving from the initial position to the final. The motion of an object can be described using a straight line motion graph. The motion of the hare and the tortoise has been represented as a straight line motion. As shown in the graph, the tortoise moves at a constant speed from A to B. The tortoise is in uniform motion, while the hare is not in uniform motion. Similarly, the hare moves while taking breaks during the journey. According to the given graph, the hare moves at a constant speed from A to C and rests from C to D. After that, the hare is seen moving again at a constant speed from D to E, and then from E to F, moving uniformly, which causes the hare to fall behind and the tortoise to win. Ultimately, according to the graph, since the tortoise moves at a constant speed, it goes ahead of the hare and wins the race. V. Define inertia. Give 2 examples each of inertia of rest and inertia of motion. Answer. An object in a stationary state tends to remain stationary, and an object in motion tends to continue moving at the same speed in the same direction. The property of an object that resists any change in its state and tries to maintain its current condition is called inertia. Examples of inertia of rest. 1. When a mango tree is shaken, the ripe mangoes fall down. 2. When a bus suddenly starts moving, the upper part of the passengers' bodies tends to remain at rest, while the lower part in contact with the bus moves forward with it. As a result, the passengers lean backward. Examples of inertia of motion. 1. When a passenger jumps off a moving bus, there is a risk of falling forward. 2. In long jump, athletes take a short run up to cover a longer distance. V. Mention the relation between mass and inertia. Answer. Both objects with less mass and those with greater mass tend to remain in their current state. However, their ability to resist external changes differs. Therefore, all objects possess inertia. The inertia of an object depends on its mass. As the mass of an object increases, its inertia also increases, and as the mass decreases, the inertia decreases as well. V. State Newton's first law of motion. Answer. According to Newton's first law of motion, an object at rest remains at rest, and an object in motion continues to move at a constant speed in the same direction unless acted upon by an unbalanced external force. X. Give 2 examples that show the resultant force changing the state of motion of objects. Answer. 2 examples showing how an unbalanced force changes the state of an object. 1. While playing, when the first player kicks the football, the net force applied by the player's foot makes the ball roll in the direction of the force. 2. The effect of the net force applied by the engine while driving a bus on a curved, hilly road. X. Explain, based on high velocity and the first law of motion, why bus accidents are more probable on winding roads in mountainous areas. Answer. High-speed buses on winding mountain roads are more prone to accidents due to inertia, as explained by Newton's first law. At high velocities, the bus's tendency to maintain straight-line motion clashes with frequent sharp turns. Passengers and unsecured objects continue moving forward even when the bus abruptly changes direction. This inertia makes skidding or rollovers likely if braking or steering is miscalculated. Additionally, steep slopes and uneven terrain further reduce control, increasing accident risks. She. State the second law of motion and prove that F equals ma. She. State the third law of motion. Answer. Newton's third law of motion states that when 2 bodies interact, they exert forces on each other. These forces are equal in magnitude and opposite in direction, but they do not cancel each other out. She. Give 2 examples of daily life activities based on each of the 3 laws of motion. Answer. Newton's first law of motion. When rolling comes to a stop, when bouncing on a trampoline. Newton's second law of motion. Walking becomes faster when carrying a heavy load is removed and walking empty-handed. When reducing the load of a truck moving uphill, the speed changes more quickly. Newton's third law of motion. When rowing a boat, when launching a rocket. XIV, 2 activities for each of Newton's laws with related law and explanation. 1. Newton's first law of motion, law of inertia, activity. Newton's law related explanation. A book stays at rest on a table. Newton's first law. The book will not move unless an external force is applied to it. Passengers jerk forward in a car when it suddenly stops. Newton's first law. Due to inertia, the body wants to keep moving even though the car has stopped. 2. Newton's second law of motion, F equals ma, activity. Newton's law related explanation. Pushing an empty versus loaded cart. Newton's second law. Heavier carts need more force to accelerate, showing F equals ma. Kicking a football with more force. Newton's second law. Greater force causes greater acceleration depending on the ball's mass. 3. Newton's third law of motion, action equals reaction, activity. Newton's law related explanation. Rocket launching upward. Newton's third law. Rocket pushes gases down. Gases push the rocket upward with equal force. Walking on the ground. Newton's third law. Foot pushes ground backward. Ground pushes foot forward, helping us move. XV. Separate actions and reactions in the following activities. Tennis. Racket and ball action. The racket applies force to the ball. Reaction. The ball applies an equal and opposite force to the racket. Jumping off a rock action. When you jump off a rock, you move forward. Reaction. The rock moves backward because an equal and opposite force is applied on it. XVI. Define elasticity and plasticity with examples. Elasticity is the property of a material or object to return to its original shape after being stretched or compressed. Example: a rubber band or an eraser stretched from both ends. Plasticity is the property of a material by which it undergoes a permanent change in shape or size when force is applied. Example: when you press or shape clay, it retains the new shape and does not return to its original form. This shows plasticity.
Thank you.